Okay, I think we start. So 100. You know what? 110. This is the score I'm giving to OpenTelemetry Metrics for the metrics frameworks categories. And now you probably ask yourself, how did I get up here in GeeCON giving scores to metric libraries? So let me tell you my story. So first, my name is Asaf Mesika. I'm a principal engineer in Stream Native. Got my degree in 2000, and actually went in the industry 10 years without even knowing about metrics, using them. First time was in 2010, back at Cotendo, which was acquired later by Akamai. Installed my first Graphite, used OTel Metrics, and then later on, 2015, I started working at Logs.io, worked there for 8 years, and Logs.io is an observability software as a service. So of course, I learned there about logs, metrics, a lot. So I gained a lot of knowledge about it. And roughly about a year ago, I joined Stream Native. Now there were two reasons that I really liked. I joined Stream Native. One, it was fully remote. This is everybody's working from home, no office. And this is something that I really wanted to try because I really liked it from COVID. And the second thing, when I was working at Logs.io, I bumped into a software called Apache Pulsar, open source software, and I fell in love with it. So that was like 3 years ago. And then I wanted to work on a company, and I searched for one, and I found one. So Stream Native basically offers Apache Pulsar as a service, and I work on Apache Pulsar team inside Stream Native. So I want to explain to you why I fell in love with it, to explain to you then how I get to actually to the metrics part. So just like 1 minute, what is Apache Pulsar? So you can think about it as if you marry two software, Apache Kafka and RabbitMQ. Why? Because it's like Apache Kafka in that sense that it's horizontally scalable. And you can consume messages in order, just moving the offset. So and of course it's performant, very performant. And the second thing is that it's like RabbitMQ, that it allows you to say, I'm done with that message, not done with that, not done with that, done with that, like sparse acknowledgement. So basically it gives you those two words in one software, and it's highly performant. And I want to show you like 3 features that got me really to fall in love with it, just to understand it. So first one is rapid cluster scale-up. Pulsar allows you, let's say that you have suddenly a spike in the incoming traffic, and you need to go from 10 to 30 instances of brokers. And you can do it under 1 minute. So how? How is it even possible? It's possible because of the architecture of Apache Pulsar. It has brokers, like Kafka has, but when a message is received, the message is usually saved to a file, right, on the disk, but not in the case of Apache Pulsar. It is saved actually to a virtual file, an append-only virtual file in another system called Apache Bookkeeper. That allows you, effectively, that means that the broker is stateless. So you can spin up from 10 to 30 under 1 minute. And of course, Apache Bookkeeper itself is also, you can scale it up. There's no data shuffling. The second thing, it comes with geo-replication built in. No mirror maker, all this stuff. You can put a cluster in US East, cluster in US West, and it's seamlessly working and replicating. And the best part is that the client also does the seamless migration when something is failover. That's brilliant. Third one, tiered storage. So you can basically have unlimited retention, because the data simply shuffles automatically for you onto to S3. So that's the best 3 features that I liked. But there's one more thing. It supports up to 1 million topics. And that's something that you can do because you're not bound to file descriptors. The files are virtual. And then you ask yourself, wait a minute. How do you monitor that? I don't want to 1 million topics. I mean, every topic has 100 unique time series. That's 100 million unique time series. That's very expensive. This is me at the end of May 2022, last year, when I joined Stream Native. I got this small task, basically a mega epic, to solve that problem. So, started doing the design, thinking, and I said, okay, let's do aggregation and filtering. Let's reduce the kernelity. Instead of having 1 million topics, maybe we can group them. Okay, we can group them to topic groups. Instead of 1 million, we're gonna have 1,000 topic groups. That would reduce the cardinality, right? But it's something very deep in the software. So in order to change that, obviously the prerequisite is to have a single metrics library. The thing is, Apache Pulsar was started writing in 2012, back in Yahoo. So you could imagine you have legacy. So we have 4 different ways of defining a metric and exposing it. So as you can think, I needed to consolidate everything in my design into a single library. So that allowed me to make a choice. As I told you before, I'm almost 22 years and started metrics in 2010. So I know most of the options, okay? But there's one that I didn't know, OpenTelemetry Metrics. Now let's explore them like just under 1 minute. We have Drop Wizard Metrics. That's the metrics libraries, and it's like the father of all the libraries. Problem is, it's too old. It doesn't support labels. Okay, there's something that's very, very common today, right? You have a metric name, you have a value, but you record it in light of a context, like what's the HTTP status code. Doesn't support that. Second thing, you have a Prometheus Java client. Prometheus is a time series database. Comes with a client. It gives you the ability to define gauge, histogram, counter. The thing is, it's tightly coupled with Prometheus. It's only the Prometheus protocol. Also, if you try to run, let's say, 100,000 unique time series on one host, you will get a lot of performance issues. Try to talk with the developer. Unfortunately, wasn't really interested in really improving it. So we have micrometer. Micrometer, this was supposed to be the big thing, right? It's supposed to be the Self4j for metrics. Everybody is using Self4j for logging, right? So let's do it for metrics. And they tried. Thing is, didn't caught on. Try searching in Maven Central how many people are using it. You won't find that much. So the only one on my list that didn't know, OpenTelemetry Metrics. So I took the time, took 1 month, read everything, like everything that there was to know about it, in order to write the design. And I can tell you, that's the score I gave it. A+. Why? First, the architecture is amazing. If you read how they wrote like the implementation, the design, very elegant. And I will show you. It had features I didn't even think about, and I really thought I knew everything. And as opposed to Micrometer, they, from the get-go, said, we're going to do it as a worldwide standard. And you cannot do a worldwide standard with one company behind it. You have to have a lot of companies behind it. And it's got to be in a foundation, not just a repo that is under your control. And that's what they did. So in order to understand Open Observability Metrics, we need to spend 2 minutes to understand what is Open Observability as the project. And then we can zoom in into the metrics. So I don't know if many of you know it, but so Open Observability as a project, the scope of this project is to give you the ability to define and record and ship your metrics into somewhere, be it your time series database, your vendor. That's the scope of the project. And it's about not just metrics. It's about logs and also traces. And it's built from 4 components. Let's cover them really quickly. First one, the API. As you would imagine, it's a bunch of interfaces. Those contains method that you're going to use to define your metrics and to record measurements, to report them. And not just metrics, log and traces. That's the API, interfaces. Second thing, you have the SDK. Of course, the SDK contains the implementation of the interfaces, yeah? But it has also extra functionality. It contains, let's just cover 3. 1, transformation. Maybe you want to do roll-up on your metrics. Maybe you want to drop them. That's like transformation. Second thing, you want to export them, right? Maybe you want to expose an endpoint / metrics to get them. Maybe you want to push them in another protocol that I will cover called OTLP. So that's the export part in the SDK. Third one, it's called auto-instrumentation. So we all use open source libraries, right? So what this auto-instrumentation will do, it will simply take all those libraries and will add metrics for you automatically. Okay? That's the SDK. Third, so we had the API, that's SDK, now the OTLP. OTLP is the protocol, is the most efficient protocol they invented to transmit metrics, log, and traces. Outside where? It can be a vendor, or of course it can be the OpenTelemetry collector, which should soon show you. Now, everybody's like, protocol, it's a big thing, scary. No, it's not. What is a protocol? It's data and how you ship the data. And what is data? It's the schema. So at the end, it's just a protobuf descriptor that describes how the metrics, log, and traces are described, or a JSON schema. This is the data. And what about how do you ship the data? So we have 2 ways. One, protobuf encoding, like binary, over TCP. It's called gRPC. Second way is HTTP. So the body is protobuf encoding, binary, or JSON, just plain text JSON. That's a protocol, OTLP. Last one, the collector. So the collector is a lightweight process that gives you 3 things. One, it has the ability to receive, like receive metrics. Maybe it will go and fetch them for you from /metrics, or it will listen for, let's say, OTel gRPC. So many ways of receiving metrics, not just metrics, log and traces as well. That's the receive part. Transform. Maybe we want to do again, roll up, drop. And you have the export. Now, whatever past the pipeline, you need to ship it somewhere. Okay, it can be Cortex, it can be Prometheus exposing a /metrics, or just sending to logs.io like a vendor. Okay, so, and the idea here is that all the heavy lifting is done here, because here you have many, many plugins for any of those 3 things. So many vendors and many ways to transform and receive. That keeps your SDK very lightweight. Okay, so we showed the 4 components, right, of the project. But again, there's one more thing that I really liked about the project. It has specifications. Now, why? They wanted this project, okay, this library, to be available in any language, not just Java. Go, Rust, Python. And they said, we want to make it look the same. So they defined in the specification, they wrote a document that specify how the API would look like, the methods and the names, and even how the SDK is designed, is built. So if you move from OpenTelemetry, from Go into Rust or Rust to Java, it looks the same. So that was the project, OpenTelemetry project, like a quick explanation. Now, let's get to the metrics part. Now, before I went to the metrics part, just one small thing I want to explain. The current situation. Let's assume you are an open source developer. You wrote a library, okay, and you want to expose it. You want to expose the metrics into the application that you're using, right? You have 2 ways of doing it. One, you're going to write an extension, okay? An extension that will basically register metrics in a metrics library. So you have to write one for a drop wizard, one for micrometer, maybe one for Prometheus, and maybe other libraries. It's too much. You won't do it. It's too much work. You end up doing that. You define an interface, okay? And any method is an event that happened. If it's an Ikari, this is like an example for Ikari connection pool, connection open, and then you will basically, you as a developer using Ikari, you will implement that, and then it will connect it to your own metrics framework, whatever it is. That's what people actually do. That's the current situation. OpenTelemetry wants to create this standard. If everybody adopts OpenTelemetry, and I think they will, this is how it will look like. Ikari, when you instantiate it, you will only give it the OpenTelemetry interface instance, and it will use for metrics, logs, and traces. But it will take time, okay, and more people like me lecturing. Until then, what the community did in OpenTelemetry is created extensions. So you can have like 2 lines of code to add metrics to an existing framework that didn't yet made it. Hint, they use reflection. So this is the goal, like the holy grail of OpenTelemetry, how it will look like at the end. So now I want to go deep dive into the API. Before I do that, I want to explain a few concepts to understand the API. Let's say I have an HTTP request that I'm making, got a response back, I want to record it, like the latency. Usually you want to do it in, you need an object, right, to do the recording on. That object is called an instrument. That's the terminology in OpenTelemetry. It's like an instrument, like not a physical instrument, right? A virtual one that you type in the measurements every time, right? Second thing, that the latency, the number itself, it's called the measurement. And the last thing is that you record that number in light of a context, like the status code and the method that gives you the ability to do the drill down, right? So that is called the attributes. It's pairs of name and values. In other libraries, they call it labels. Here it's attributes. Next concept, it's a meter. So what is a meter? A meter is a factory for creating instruments. But there's one interesting thing. It has a name and a version. Why? Because when you create instruments for a specific meter, it's like it groups them into that meter. They belong to that meter, and they will receive the name and the version you give. What's the idea? If you are an open source developer, you will define your own meter, and you call it like Ikari, and you give it a version of the library. And if it's your own application, you would create your own meter, and then you would know it by the name and the version. Okay, last is the meter provider. The meter provider, well, you need a factory for meters. So this is the factory for the meters. And second thing, it contains all the configuration of the SDK. You need to configure the SDK itself. Okay. Now let's cover the next in the API is the instruments. So all the instruments, never mind the type, has name, description, and unit. Makes sense, right? Okay. First type of instrument, counter. I think it's obvious, lots of people know it. It's a number that only goes up. Okay, for example, what's the size of all the received messages from the beginning the process started? Easy. Of course, you only add positive numbers, right? Makes sense. Only go ups. But I want to highlight one thing. Is that the attributes, okay, in the Java SDK. The SDK here in Java, it gives you the ability, instead of placing the attribute, the producer attributes, you can create them once, and then simply reuse those attributes, and then you don't have to allocate memory and create them again and again, something that happened in other libraries that will consume memory over and over again. Here you can create them just once and use them. Like in Pulsar, if a client creates a producer, usually the producer lives for a few hours at least. And we have some representation of that producer inside Pulsar broker. So what happens is when I create like the producer class, I create when I construct it, I create the attributes like that, the producer name, and I keep it as in the instance of the producer. So I can reuse it whenever I record the number. That's something that is important to highlight. Okay, that was the counter. Next, up-down counter. It's a number that can go up and down. Like in-flight request, how many HTTP in-flight requests I have? Okay, that's really easy. But if people use the Prometheus, they say, no, it's called a gauge, right? Well, it is called it is a gauge, but there is a gauge here. There's also a third type called a gauge. But why? It's a bit confusing, right? Because the gauge can go also up and down. But in OpenTelemetry, they wanted to convey something. If you use a gauge, you basically say what you're saying. Let's say you have 3 rooms, and you have 3 sensors measuring the temperature, and you want to record the temperature, and the attribute is the room number. Okay? Does it make any sense to summarize the temperature, 52 degrees plus 26, like across the rooms? It doesn't, right? So when you create a gauge, a number that can go up and down, you're making a statement. Every number stands on its own with its attributes, like the temperature for the room, and that's it. That's the thing that you say. That's what the gauge means in OpenTelemetry. And to somehow mark that in the API, you use a callback. Okay, so you register a callback when you create an instrument, and like every 30 seconds or 60 seconds that something is coming to get all the metrics, it will execute your callback. And your callback will simply give the value, the current value, like the current temperature. Okay, that was the gauge. Last type, histogram. Now, histogram is about just recording numbers, okay? And when I ask the value, it gives me like a statistics on those numbers. Usually it's used for like latency, right? You record many latencies, and then when asked, I will give you like explicit bucket histogram is a good example of an histogram. You give me bucket ranges, and for each bucket I will tell you how many measurement latencies I saw that fall into that range of the bucket. Okay, that's an histogram. Here's an example of the code. Okay, quick summary of the API. Not very complicated, right? You have counter, histogram, up-down counter, gauge, meter, that is the factory, and meter provider, factory of the meters. All good. Now, let's switch to the SDK. I think it's the most interesting part. Okay. I want to explain something like 2 major concepts in the SDK. The first one is called aggregations. Here's an example of an histogram, right? I said the unit, the name, of course, unit description log. Sounds simple, right? How many of you created histograms like in other libraries? Just like one hand. Okay. Something is missing here, right? Where's that? What's the bucket? It doesn't exist. Okay? Hint, it's a bit changed, but it doesn't exist. So how it doesn't exist? I'll explain to you. They have this generic representation of an instrument. If you look like in other libraries, here it's completely different. For an instrument is like a generic design, and if you think about it, it's like a box. You keep pushing values into it, numbers. Maybe you're doing an add for counter and up-bound counters. Maybe you're recording for histograms, but you keep pushing numbers, okay? And then on the other side, they say, okay, give me your current value. What's your current value? So if it's a counter, you basically just summarize all the numbers you saw. right from the beginning of the process. And if it's an histogram, same problem counter, an histogram, it will give, okay, for those ranges, I want the count for each bucket. So if you think about it, so inside OpenTelemetry, what they did is say, okay, every instrument is the same. The only difference is an aggregation. So inside is like an aggregation function, but it's not a function. It has a state. So it's basically like an instance, an interface. And so for each instrument type, you basically have a different aggregation. So for counter, it's a sum. For histogram, it's an explicit bucket histogram. That's like the design inside OpenTelemetry. And once you understand that, we can explain what is a view. And to understand view, it's just a reminder again. What is an instrument? It has a name, description, unit, right? And it has a type. Counter, gauge, up-down counter. Now we know when we, based on the type, we get a default aggregation, okay? That we're gonna use, right? For counter, it's a sum. And if it's an histogram, you also get the config, like what's the bucket ranges. So when you think about it, like for an instrument, like a view is a way, how do you want to view the instrument? Like at the end, how do you want to view it? So if you don't do nothing, you get a default view. And the default view is exactly what's written here. Everything you defined and the default aggregation. That's how you want to view it. But maybe you want to change it, okay? Maybe you want a different name. Maybe you want a different unit or a default aggregation, okay? So you can register a view. And if you register a view, you're basically changing the way that the instrument was defined. And that gives you the ability, basically, to override the way the instrument was originally defined. Okay, so let's just look at an example. Let's assume you're using HTTP Commons, Apache HTTP Commons. Okay, it's not, you didn't write it. Okay, and this is the latency. This is how it is defined. Okay, and if you don't do nothing, that's the ranges you would get for an explicit bucket histogram. Look how many. It's super expensive. Okay, nobody wants that. But what do? It's the code is like package, it's inside. No, you can, when you instantiate OpenTelemetry, you can register a view. And you can, when you register a view, you're basically giving two things. One, which instruments do you want to change? Like which instruments do you want to define a view, to do the override for? So we have something called an instrument selector. Here, let's select just one, just based on the name, just HTTP latency for our example. And then you define the view. The view is what do you want to override. In our example, I want to override the aggregation. Remember, it's an instance. So I want to define, this is the aggregation would be, explicit bucket histogram, but like less ranges, less expensive. That's brilliant. And you do it in the beginning of your application. Now I want to show you the superpower of a view. The superpower is overriding attributes. Okay, same example. HTTP library you're using, maybe it's okay HTTP. Okay, or some other. And let's assume that when they wrote it, that's the attributes they're using. Status code and source IP. So when you record the 30 milliseconds, okay, you're basically recording it in light of, for the attributes, let's say 500, and that's source IP. Okay. Let's say you're only contacting 3, 4 broker, like a host. It's okay, never mind. What happens if it's way more than that? What happens if the amount of IPs is hundreds of thousands? So the amount of attributes you would keep in memory is too much. So maybe your application will out of memory. You want to change that. But oh no, it's inside a library that you didn't write, but you can change it. You can say, in the instrument selector, I want to define a view for the following. And for each one, it will define. Here, only one, I selected only one actually. I give the meter, okay, which is the name of the library effectively. Okay, Apache Commons HTTP, and the name of the instrument, HTTP latency. And I want to say, I want to override. What do you want to override? The attributes. So I want to keep only status code. So what would happen if I do that, modify that? Before, this was recording to 500 and this is source IP. Now, as you do the record, before it goes into memory, it actually changes it and record it only to 500. Boom, memory problem solved. Okay? And the code is, you cannot change it, but that's brilliant. You solved the problem of the memory. You can't do it with any other library. That's brilliant. Third thing you can do with a view, copy paste. You can view it differently, but multiple ways. You don't have to define one view. You can define multiple. So view 1 can be exactly like the default. But view 2 and view 3, you can decide to have. So what happens is if you define more than one view, they all get the same input. Like all the measurements will flow into them. So basically, you're creating 3 different instruments, okay, based on the overrides. Here's an example. I register a second view on top of the default view. And here, what I do is I'm overriding the name. That is the name now, HTTP latency counter. Okay, and here I put a stupid example. I change the aggregation. Now I will get the summary of the sum of all the latencies, okay, in a different counter. But you can change many, right? You can change attributes, you can change many things. Just imagine what can you do with it. So you're basically viewing it differently. Last example of view. Wildcard. So what do I say here? I say, please select for all the instruments that end with the word latency, I want to define a view, okay, like replace the default view, and override the aggregation. I want this explicit bucket histogram, and those are the ranges. How do you do it in other libraries? You have to define a constant, and you have to share it, right, across all your instruments. Okay? What happens if, maybe I don't want. I want all the instruments, I can do it one time. And in the initialization of my application, when I define OpenTelemetry, I can do it once, and all the latencies would have those buckets. Even ones that I didn't even prescribe to. Let's summarize views. So the view actually gives you the ability to fix, okay, your library, to fix instruments of libraries you didn't even write, like open source libraries, matching your needs. You can apply a bucket config, as we showed, to many instruments at once. You can reduce the cardinality. That's amazing. Okay, if you remove attributes. And you can use the same instrument's data, but twice or maybe a couple of times, viewed differently. Okay? That is view. One important element that you use in SDK. Let's go to the last one. The last 3 elements I will explain together about the SDK. Okay. So, we have something called a metric reader. So you have the instruments, right? They have data. You want to do something with the data. You want to read the metrics. So you have a metric reader, essentially an interface, an object that gives it the ability to read the data and then do something with it. Okay, one important element to note about a reader is where you define, basically, this is where you define the mapping between the type and the default aggregation. That means that here is the place that you can say, you know what? For all the histograms, the default one would be not explicit bucket. This is old. Let's use exponential bucket histogram. There's something new that OpenTelemetry has. So this is the place to do it. when you create a metric reader. Okay, when you register a reader, what happens is that OpenTelemetry, the SDK, gives the reader something called a metrics producer. So a metrics producer is a very simple interface, very simple object, as like one method. Give me the aggregated metrics. So it goes into the memory, goes over all the instruments, and gets the current value, okay? Based on the aggregation. Okay, so you get a list of all the aggregated metrics. And then you have to do something with it, right? So let's look at examples that come bundled with the SDK. One reader is called Prometheus HTTP server. So what does this reader do? It is bundled with OpenTelemetry SDK, Java SDK. It spins up an HTTP server, okay, and exposes like a /metrics endpoint. You do a GET request. Whenever you do the GET request, it will call the metric producer, get a list of all the metrics, transfer them into the Prometheus exposition format, it's a text format, and then just write it into the response body. Okay, that's the Prometheus HTTP server. That's one reader. Another example is different type of reader. It's called a periodic metric reader. You define an interval, and every interval, let's say every 60 seconds, what it does, it calls the metric producer. And then it gets a list, and then it needs to do something with that. So there's a third interface called metrics exporter. So metrics exporter, you give it the list of metrics, and it basically ships them somewhere, okay? Because it's an exporter. You have couple of exporters, like the main ones. For example, let's say it's a gRPC OTLP. Send it in gRPC OTLP format, or maybe it's a OTLP HTTP. Okay, so you have different metric exporters that you can choose when you create the periodic metric reader. Let's summarize. I think that's a good time if you have questions. I see we have a lot, but good if you wanna pop some questions, it's a good time to do it now in the sli.do with GeeCON code. So basically, if I summarize, I think that this library is the future of the metric libraries. In my opinion, it will deprecate all the others. Okay, it's obvious. It's way better than them. And the thing is, the community is brilliant. I mean, I had so many questions in the beginning, and you go into the CNCF Slack, and you go into their channels, and they give you a lot of help. Now, I needed to do some sophisticated things, get it to super high-level performance, because Apache Pulsar is a very latency-sensitive system, like Kafka. So you need to be let's say, under 5 milliseconds for every message. Okay, so I started working with the maintainer to improve it, and we discussed, we brainstormed, and he's all for it. Didn't happen to me with other libraries, and I tried. So I really like that approach. So I suggested, and after 2 months, he wrote 60% of it. Reduced the memory by 98%, the memory allocation, just for an example. And there are more things that he's working on now, and I'm supposed to help him. But what I want to say is that this library has great community, great standards, and great feature set. And together, coupled with the collector, I think it's brilliant. So that's basically it. I want to cover only 2 more things that I actually have way more time than I thought. So just cover in under 1 minute 2 additional features in the SDK. Something called a semantic conventions. Okay, semantic conventions is that sometimes you look at the trace or log or a metric, and they have this different attribute. One is called host name, another called the broker or something different. So they decided on a standard for the same field names. So if you're using, let's say, an attribute name, or maybe it's a field name in the log or in the trace, they're all the same name. So host name is a specified constant in the Java SDK that everybody is using, like for the metrics, log, and traces. So when you do the correlation between them, you can configure links between Elasticsearch query and Lucene and PromQL. You can easily do the translation because they use the same attribute name, and you grab, of course, the value. That's really, really, really good. So that's semantic conventions, like names for many, many entities. The second thing, they have something called a temporal aggregation. Temporal aggregation, yeah. So that means that you can define for certain instruments, they support like two aggregations, two temporal aggregation. One is called a cumulative, as you know, right? So the aggregation only keeps getting bigger. It's like from the beginning of the process. You count from the beginning of when the process started. And you also have delta. So you can say every time you run /metrics, it will give you the delta of the value since the last time you collected. That's really good if you use, let's say, OpenSearch as your time series database, because it doesn't really know time series OpenSearch. It's only good for summarizing, only good with delta, okay? Because it's hard to do rate in OpenSearch or Elasticsearch, for that matter. So you can actually say, you know what? I want that metrics in delta because I have Elasticsearch or OpenSearch. So that's temporal aggregation. So that's like only two things that additional they have. So that's it. I hope you gained the knowledge with it. And now we will go to the questions. Thanks. You want to I swapped.
Yeah. No, you don't. Yeah, you need to put it in the big screen. It's the best way.
This is on my laptop. You see?
Okay, could you move it to the second screen?
I'm sorry, I can't.
Maybe it's not so important, so you can just answer questions.
Okay, so I will just read them out loud. I have this here. So for traces, should I use OpenTelemetry or OpenTracing? OpenTelemetry. Because OpenTracing was the standard before, and basically they did work, the communities, and now they're basically merged into OpenTelemetry. Is there some graphic representation on top of that so that the metrics can be presented in form of graphs? Not in OpenTelemetry, maybe in the super far future. The scope, as I said, limited to defining, exporting, and shipping metrics, log, and traces. It's unrelated to, you have, of course, Grafana and this new project called Perez, I think, or something like that. It's a brilliant new UI. But no. Why? Okay, next question. Why should I care with logs if they should be logged to STD out? The rest should be done by infrastructure. Can you elaborate, the person who asked that? Okay. What? You say, why bother having the OTLP protocol? Why bother using it? That's the question? Okay, I hope this was the question. So basically, just think about it, is first, STD out, no structure. You have to do parsing, right? That's one thing. Okay, yeah, you can do JSON, but that means you have another software for doing the parsing from the JSON to that, how to read, okay? You can say, I'm shipping it in OTLP to, let's say, the collector, okay? And to STD out, I will print human readable. Like, no, JSON is hard to read, right? And you do kubectl, right, on le, or just do tail. So we can, like, do twice. You can ship it right to console, to the console, but also ship it to OTLP. And in the collector, you have this centralized thing in this collector, OpenTelemetry collector, you can do things. You can drop, you can relay it, change it. I think it's better this way. OpenTelemetry collector adoption by cloud providers. Cloud Ops agent in GCP looks like OpenTelemetry collector, but it is custom. Yes, I will explain. OpenTelemetry collector, as I showed, has receive, transform, and export, right? And it has plugins for each one of those three. What the vendors do, usually, they like build it. So they put the plugins they want, like the plugin that ships to AWS or maybe to Google Cloud Service, the log traces like to the correct places. And then they bundle it and package it into a Docker image, or maybe one binary, and that's it. And then you use their distribution. So many vendors distribute OpenTelemetry collector matching their plugins. So that's, I hope, this is a question I answered. Is this a replacement for Micrometer and or Prometheus? Does this tool add complementary or unique functionality to your system? Okay, first, I hope the second question, I hope it was evident from the lecture. But regarding the first one, yes, it is a replacement for Micrometer. Okay, you should move, in my opinion, should move out of Micrometer into OpenTelemetry API, like the Java SDK or other languages, and use it. Extra functionality, views. Hands down, views. It's like reduced cardinality, control, brilliant. What are the performance overheads? How long does it take and how much memory is it needed? Okay, so I only know about, so for metrics, it depends on your application. Again, if you have like a normal application, I think it's okay to use it now. If you have like super sensitive, I'm only talking about the metrics. I don't know about logs and traces. I haven't delved into that code at all. Okay, it's the same SDK, but didn't touch it. I can tell you that for super sensitive application, they are right now like fixing everything. Like they pushed code to reduce, I think by 70 or 80% all the memory allocations. So if you're super sensitive, like milliseconds, that I think you should wait just a bit, but you can even test drive it now. My goal this year is to hopefully implement that design in Pulsar, and that means that it has to be conform to low latency. Metric from logs versus program metrics in code. What is the trend? Oh, it's a bit out of scope of the lecture. I can give like a quick response. We still have time, right? 5 minutes, okay. Yes, of course you can deduce metrics from logs, but I think it's, in my opinion, it's hard to, like when you do like, when you log and you do structured logging, not many do it, by the way. Many just write a string and that's it, right? And you have to parse it to get the extra values, the numbers, the latency. Not many people do structured logging. Like that it actually comes with a field, and that field is translated into JSON. And many people, what happens if they see a log line that have this extra field? Oh, there is a spelling error, let's fix it. Okay, and you fix it, and then all your aggregations are breaking. I think it's different when they see a metric name. A metric name, they know. People are using that metric name. They build dashboards on it. I think they will less prone to change. That's why I think it's important to differentiate between the two. What company is behind? Many. It belongs to CNCF first. Okay, that's important. And so many companies, I mean, if it's the second most active project in CNCF. CNCF has many projects. And if you look at the amount of contributors and the companies, you would be amazed. Is it possible to dynamically configure the metric aggregations, reduce or increase cardinality on a live system? No. You can do it. Something that I thought about, like trying to modify it. I think for now, the way it is designed, it's hard to do it. So, but normally, I think it's usually if you just change the you can. I think you can just change it and deploy for now, but I don't think it's such a big deal. Does OpenTelemetry replace Self4j for logs? Yes. And in terms of interfaces, yes. Because you're supposed to use the OpenTelemetry API, you won't need a Self4j anymore. The thing is, interesting enough, they didn't write the implementation for logs as they did with metrics. So in the logs, what they did is they wrote bridges to existing logging frameworks. So basically, SDK is effectively the API and a bridge to like Log4j or Logback. That's what I know. I'm not super expert on it. Could you share your presentation? Yes. You can follow me, Asaf Mesika, on Twitter, the handle. I will publish the link there in the near couple of days. Can I migrate from DOP Wizard to OTel in a backward compatible fashion? No. I mean, no. I think it will be. The thing is, OpenTelemetry has a different naming conventions. Like the metric names are with dots, and the same with the attributes. And you would probably want to use the semantic conventions. So I think it will be a bit hard. Maybe it's possible, but I think it's hard. Like I can tell you that I'm designing it now for Pulsar, and everything is already defined. It's going to be a major breaking change, but I think it's needed. Last question: is it possible to record metrics from file with just simple binary OpenTelemetry agent? So you mean that the application would write the metrics to the file, and then the OpenTelemetry collector would pick it up? Can you elaborate, that person? That is your intent? Okay, so you can write your own metric exporter, okay? And then in the exporter, you can do whatever you want, because you get the list of metrics and you can just dump it to a file. If it's your own format, you would have to write a plugin in Go for OpenTelemetry collector, the receive part, okay? And then just read the way you like, and then ship it to whatever vendor that supports the shipping one, right? You have many. Out of time. Okay, thanks a lot for your attention.